ideal in nature. But understand, this is exactly how the concept works. After some point of time, I'll get 50%. Frame this, 50% is left or 50% got used up. What do we use? What ratio do we use? 50% of the thing is left. Correct? The 50% got used up to form what? Products. The word formed is always associated to the products. Always. Okay. Next, 25%. What is this? Left or used up? Guys, come on, focus. 25% is left. Which means product was 75% formed. After some point of time, 0% is left because 100% of the product got formed. Any doubt here? No. Here, I have not represented any kind of equilibrium. I have not done it. Okay? But this is exactly how the concept works. Now listen, I'll start drawing arrow marks. From 100 to 50 is my concern right now. 100% we started off. After some point of time, 50% was left. To come from 100% to 50%, do you think it's going to take some time? Obviously. The time it takes to become exactly half of its concentration will be called as half-life. What life? Half-life. Okay. Now, from 50%, I'm supposed to calculate half-life. I should connect this line to what number? Correct? So let's say from 100 to 50, it took 10 minutes. From 50% to 25%, it will take the same time. So how much time here? If I'm trying to go from 25. 12.5. How does 0? Hey, run it. Half of it. 12.5. Half of 25 is 12.5. So to go from 25 to 12.5, it again took 10 minutes. So can you see? Initially, it's taking a bigger jump. As time keeps on passing by, it keeps taking slower amount of jumps. Okay. After 12.5, it becomes 6.25, then 3 point something, then 1 point something, then point something. After a lot of time only, it becomes 0. People always get confused. From 100 to 50, it came up in 10 minutes. They'll think from 50 to 25 is going to come in half the time. No, it will take the same time. That's an advantage of school. This is exactly how our medicines work. Okay? That's the concept. So initially, when you pop a paracetamol or some kind of painkiller, you're gonna get immediate relief. That's because it becomes half in the same time. But even the next morning, you won't feel any pain. That is because it takes a lot of time to become half. By the time it becomes half, it's already morning. That's the concept. Okay. That's why people. Have you guys heard of people doctors telling? In this course, make sure the time gap between each tablet should be minimum 6 hours. Have you heard of them telling? That is because for the tablet which you popped in, for it to completely get dissolved meaning completely to get used up. Concentration to become almost 0. Half-life happens. Can you imagine that a tablet which is like so small, okay, is gonna take 6 hours to get dissolved? Understood why no? 50%, like this will happen. Then 25%, same time. Then same time. 6 hours gap is required. Obviously, there's something like that buffer. Plus or minus 30 minutes is there, but what is preferred is 6 hours. Because I heard, no, the main concept is because of this. Now, what happens? Now, let's say you pop the tablet, okay? You pop the tablet, plus 3 hours. After 3 hours, you popped one more. Now, what's going to happen? This leftover concentration of the first tablet will combine with the leftover of the second tablet. What's the leftover? 100%. Correct? 100%, well, let's say 30%. If you add up, how much it becomes? 130%. Let's ignore 10%, thinking that it got used up in the digestive tract. Ignore that. 130% was expected, 120% is remaining. Overdose, no? Agree? That's the meaning of overdose. Understood? So, now 120% to become 60%, it will take, let's say, 30 minutes. Example, from 60 to 30%, so all these things are left. 30% left, again it takes 30 minutes. But now, 15%, again 30 minutes. Can you see the time becoming more and more and your body is working more hard to digest it? That's the reason when people pop a lot of things without seeing the prescriptions, your body starts to shiver like this. More amount of concentration, body does not know what to do. When you start shivering, it starts producing some kind of heat. Agree? That heat is at least trying to get the concentration lower faster. But mark my words, very difficult to obtain. Okay, your eyes will start becoming more red. You will start feeling restless. You will always want to go from one place to another place, but your body is not supporting it because of whatever disease you have, fever you might have, cold you might have, whatever. That's the reason it's always, it's always recommended to follow the amount of gap given by each thing. What is the body trying to do? It is trying to attain something called an equilibrium state. It can't, obviously, because you are overdosing it. Need out here? No. Half-life, very important. Very important. Obviously, that comes under the concept called as rate of the reaction, which we'll talk about it later. No doubts, no? 100% of the tablet becoming 50%. Correct? Rate of took some time. That time is called half-life. The time at which one more way of defining it. The time at which the tablet went from 100% concentration to 75 to 50. That time is also called as rate of the reaction. It out there. So can we all agree that rate can be defined in terms of two perspectives? I want you to think and answer. Left hand side is R. Let's try to define the rate with respect to reactants. Rate of the reactants is always negative. Yes or no? Think. Why? Because after some point of time, will the reactants disappear or appear? Disappear always is negative. Rate of the products will be always positive. Reason is because appearance. Need out there? No? This they won't even call it.
Backward reaction.
It will become a backward reaction. That's why I'm still telling you. What symbol is this? Reversible symbol? No, then you can't attain equilibrium. What if is not this concept? If I put a symbol like this, then you can ask the question. Then I will tell you, not what if 100% it will come backwards. Okay. Now, best example when it comes to bio way of defining equilibrium or reversible reaction. One of the heading is reversible there. Okay. I'll tell you. Very easy example. Everybody will be able to relate to it. Vomiting. How does vomiting work? Have you guys watched videos as to how the digestive tract reacts for a vomit? So basically, there's something called as appetite, which has to do something with respect to the stomach. Okay, the stomach appetite meaning the capacity of the stomach to take the amount of food. That's how the concept is. Can appetite decrease? 100% yes. Okay, the sac of the stomach will always keep on decreasing depending on the diet you guys follow. Okay, now what happens after some point of time? Let's say you're trying to keep stuffing food. The stomach at one point of time is full. I'm pretty sure you guys have experienced the stomach fullness. Now let's say you tend to push more. Okay, it will tend to take. You will start feeling something called heaviness. What does heaviness meaning? Your stomach is trying to expand. Even on expansion, you've given it so much amount of food that the digestion process and the food intake process is not matching. Meaning, the digestion starts off after a certain seconds of you giving food to it. You are not giving the body good amount of time for it to get completed. You are telling stuff. You are confusing the body. At some point of time, it gets angry. And the way it shows anger is, you are making me do more work. So I also have a way to cut down my work. What? Instead of trying to push the food forward, it will push the food behind. If it pushes behind, it will obviously use something called as bile. What is something called as bile juice? That bile juice will help to lubricate it basically. Well, when you're trying to eat the food inside, what's the lubricant? Saliva. Saliva is a lubricant. But in order to come outside, it needs one more route. Okay. So it uses the bile juices along with a lot of gastric juices. Okay. Now, gastric juices were there only to help, like a catalyst, okay, to help the process of digestion. But you kept on putting more. It will also decide. But you are eating too much stress to the body, not required. It will push outside. When it pushes outside, what was supposed to go inside, it comes outside, and that's the concept of vomiting. Have you guys got the concept of how it works? Forward reaction, backward reaction. In both the cases, some kind of catalyst was being used, okay? Intake process, catalyst was saliva. The other process, the catalyst was bile and gastric juices, but usually it's bile. Read out here. No. Most important thing, once people tend to vomit, most recorded answer is, they'll be like, it feels a lot freer. I've heard of them telling, what's the logic behind it? Now the body has good amount of time to digest the leftover food. It's called as chyme. You remember in 10 standard. Whatever food is left in the stomach will be called as chyme, basically, that processed food. That it has process. It has time for the chyme to get processed and sent to the next part of the body. All this, don't you think the digestion also is taking some time? We call it as metabolism. Okay, metabolism is nothing but rate of the reaction. Digestion happens at a certain rate. Metabolism, reaction takes place at a certain rate of the reaction. Any doubt here? Don't forget it. Okay. Now I'll ask one more question. Every time you eat, will you vomit? No. Think and answer. No. Every time you eat, will you vomit? When you eat a lot, will you vomit? It's a maybe. Okay? But when you eat a lot, along with a lot of junk, then will you vomit? 100% yes. Okay? Now, junk does not always mean, maida or something with oil. Junk in body language also means whatever does not suit your body. Getting that's how it works. So for some people, milk might be allergic to them. So when they try to drink milk, the first thing how the body will react is not pimples or allergies. It tends to push the milk outside. If it is not possible, if it processes it, then only allergies and all these things are happening. Okay. So not all reactions are reversible reactions. Okay. And all kinds of reversible reactions will 100% have to attain a state called as equilibrium. Remember this. Okay. All kinds of, again, as I told you, almost all the time when you're trying to introduce something called as a junk to your body, it tends to push it out to the alimentary canal. And in this case, vomiting is 100% there. Ain't out there. And a lot of people also tell some kind of uneasy feeling in the stomach. It is trying to send it back, but the digestion also is happening in a much faster way. So it is in that region. Should I send it back or should I process it? Send it back, process it. This is what creates an uneasiness. It does not know what to do. Should we go to the next step or the previous step? So now what people tend to do, they tend to drink something called as hot water. Why? Add more amount of promoters, catalyst promoters. Remember all these things? But molybdenum is the most famous promoter. When Hayward process, that process is processed. Okay. So drinking hot water or drinking that kind of walking, all these kind of things, or getting into some kind of physical activity is promoter. To do what? For the digestion process. Get out here? No? Good. Now let's get back to the concept called as chemical equilibrium. Okay? Okay, just add R. Right? R. Yeah, all caps. Reversible reaction symbol. P. R. Reversibles. P. Okay. Now this is not good enough for me to explain the complete process. So, okay, fucking throw the phone. Okay. So only for my understanding, I'll go a little deeper. Now help me with this. I have R, I have P. I'll write A plus B, reversible in nature, gives you C plus T. Now by the looks of it itself, you'll be able to tell how many reactants are used in the process here. 2 reactants. What and what? A and B. Okay. Here C and D. One major mistake I made, but it is accepted in equation form. Now what's the major mistake? I have not represented either the reactants or the products in terms of active masses. Active mass in this concept means what? Molar concentration. I have not drawn brackets here, but it is still acceptable because it is still in what form? Equation form. Okay. Now for A plus B to tend to react, okay, become 1 and then to start breaking down. Do you think it's going to take some time? Obviously. Now I am telling you T equals 0. When T equals 0, meaning both A and B will be called as initial concentrations. Yes or no? Now, initial concentration of the reactant will be 100%. Now don't get confused. If I use the word reactant, it includes A and B together. Okay? I am not talking about A and B separately, together. Getting it? Now 100% of it is left over. Correct? After some point of time, the 100% becomes 90%, 80%. If it becomes 90% left off, the 10% got used up to form what? To form what? The products. What are the products here?
C and D.
C and D. Ain't out there? Am I telling only C, only T, or combined C and D?
Combined.
C and D. Now, why is that? Again, let's go back to type standard. Remember something called as major product, minor product. That is the meaning of why I'm not trying to become more general here. Let's say you're trying to do the same thing in terms of organic chemistry. 100% C will be the major product. More amount of focus will go on C compared to the byproduct here, because usually the byproduct will be some kind of water, some kind of alcohol, which is not required. That's how things work. So to be more general, we'll keep on using our products compared to either only C or only T. No doubts there? Cool. Now A plus B trying to become C plus T. This side is always called as forward reaction. Always. Okay. What you're trying to do is eating, digestion is forward in nature. Okay. If it puts back, that is called as backward, also called as, happens only if it is reversible in nature. Backward reaction. Now remember, this also will take some time. This also will take some time. Read out there?
No.
It will not happen within a jiffy. Remember this. It will always take some time. The reason I gave digestion as an example is because everybody in the class would have experienced it. Getting it? So it is not happening instantly. The moment you put food, you are not coming and vomiting also. It will take some time. That's it. Now you might tell me, sir, it's only happening within 10 minutes. That depends on body to body. Okay, depends on how immune you are at that moment of time. If you are feverish, non-feverish, and all those things. Getting it? But it is never instant. It is not like you put food, it's gonna come out. No, it always takes some time. taking time for the process to take place is called as what? Rate of the reaction. That's all. Got it? As to how things work? Fine. Now, supposed to draw graphs. Do one thing. Draw this now. Do not write the 100%. Apart from that, write everything else. A plus B, reversible, C plus B. Below that, one arrow mark gives you forward, other arrow mark gives you backward. Huh? Hey. Wait, agora. What's that tomorrow? Appa. Where? College only. Hey, you went for rehearsal now, bro. You didn't go. You don't go main tables. Hey, not everybody should wear dhoti. You know, they can wear all these ethnic. You should wear basically. Don't be wearing. Then, guys. Next, right? Heading as graph. Okay, look at the word for a second. I am not using the word reactants. I am using A and B. Okay, I'm using the word and. As time keeps on passing by, the concentration of A and B will keep getting lower and lower, or higher and higher. Lower and lower. Okay. As time keeps passing by, the concentration of if I mean concentration, what exact talk about? What concentration? Molar concentration, or also called as active masses. Okay. As time keeps on passing by, the molar concentration of C and D keeps on increasing. Any doubt there? No. So we got to represent both the lines in one single graph. Now how do we do it? We'll obviously use two axes. The x-axis talks about time. The y-axis talks about concentration. Okay. Now listen. This is called as the origin. In terms of number, origin means what number? 0. Now think without blabbering, you tell me, which side starts off from the number 0? Left side or right side?
Right side.
What? Product side. Product side. Reactants haakila and the products barata. What do you think how it works? Always the product side becomes 0. Starts from 0. Okay?
But in a reversible reaction, you can't tell what is the product.
That's why I'm using the word starting. Understood?
Real consume memory video. Real consume memory video.
What?
If you don't send follow request, you can't fall in love. Simple. Okay? Okay, that's all.
Signal.
And yeah. Okay, now listen. So what starts at 0? The right side, product side. So, okay, we'll start with the product side. As time keeps on passing by, the concentration of the products keeps on increasing, and after some point of time attains a certain stage. Always like this. Okay. Now, we start the concentration. I'm not until 100%, but almost 100% only. We start off with. So, almost here I start. As time keeps on passing, the reactants tend to go down in concentration or become higher. Go down and attain a certain state. Now, obviously, you'll ask me a question. Why is it attaining like this? See, I'll tell you. This is exactly why I taught you half-lives. Okay, let's get into a little bit of math right now. Okay.
What is half-life?
Okay, I'll take off this number 0. 100 becomes 50. 50 became 25. 25 becomes
12.5.
12.5 becomes
6.25.
6.25 becomes
3.1.
no, do the math.
175.
Pakka na?
Pakka.
Something of blabbering.
No, sir. Right. 175.
This becomes no, do. I'm telling you.
1 point.
So it's 3.125.
ಗೊತ್ತಾ ನನಗೆ ಗೊತ್ತೇ
No,
ಇಲ್ಲ.
no.
Hey!
2 I'll give you fucking. 1.5875 by 2 ಮಾಡು. ಮಾಡು. 0.7 ಏನು? by 2 ಮಾಡು. 791. Next term. ಅಲ್ಲ ಬರಲ್ಲ ಮುಂದೆ ಬೇಡ.
0.3956.
ಹಾ ಮತ್ತೆ
0.197.
ಮತ್ತೆ
0.098.
ಮತ್ತೆ ಮಾಡು
0.049.
0.0.
0.024.
Wait, listen. I've gone till here. Let's count number of steps. 100 to 50, first step. 50 to 25, second step. Third step, fourth step, fifth step, sixth step, seventh step, eighth step, ninth step, 10, 11, 12. Yet, we haven't got 0. Correct? We will never get 0. That's why, after some point of time, since we can't keep going lower, it tends to plotting of the graph becomes almost a straight line. That's the meaning of it. You guys did Ojai Vanalo in 10th standard. Those small, we will tend to ignore it basically. We'll be like, okay, almost the thing is there. So this way, the main point, this is the main point. We connect directly. That's how concept works. So is it exactly a straight line? No. So how will the line be? It will be like this. Okay, it will keep going like that. It won't come 0. But if you look from behind, it almost looks like a straight line. Almost. Any doubt there? So I'll tell you where does this exact thing start off from. Can you see till here, we had some actual number before the point. From here, it's always 0, 0, 0, 0, 0, 0. 1, 2, 3, 4, 5, 6. I've gone 6 steps deeper, yet I've not got the answer as 0. But if you count the number of steps here, 1, 2, 3, 4, 5, 6. Same number of steps, it became 100 to 1% within 6 steps. From 1% to 0. From 1% to 0%, it is not at all happening. Can you see the change? So same number of steps, 6 here, 6 there. 100 to almost 1. 1 to 0, not happening. That is why I straight. Understood? Why half-life is important? If this is behaving a certain way, this also will become the same way. So do you think 100% of the product can be found? No, it will be like 99.91. Sorry, 99.12, 99.28, 99.45, 99. Whatever. You will never get 100%. You will still be getting 99.989899. All this thing will be happening. So it's always like this. Okay, from back if you see, it looks parallel to each other. So at one point of time, that basically the 0 point. Understood? At one point of time where we tend to not believe all the values and assume it to be stabilized, that point of time we will try to attain equilibrium. Got the concept as how it works? I mean, in college they tell it will become a straight line. It won't become a straight line. I'm telling you, we are assuming it to be a straight line. But the thing is how it works? Because explanation is here. It cannot become 0. Again, even if it keep telling me, I can go 6 more steps, yet it won't become 0. Correct? No?
Sir.
What's on it? Huh?
Two.
I'm not you. Probably that. That's the meaning of it. Probably that I know. That concept of equilibrium.
I finished in college.
That doesn't matter. Then why you're asking the rate then? I mean, half-life.
I was with senior.
Haha. Yeah, bro. Let's now see. Now see how well rate better. See that? I don't go that far outside. 17 will become 17 pieces. But okay, now since look at the this process. Since the reactant side initially is going faster, from 100 to 50 it came in one step, no? Getting it? Since it's becoming so fast, can we tell until it reaches equilibrium? Okay, the rate of the reactant, okay, it will be a forward reaction. Agree? Which means the rate of the reactants getting, lower and lower. I'm talking about concentration. Okay, is higher compared to the rate compared to this rate, backward reaction. That's the meaning of it. Okay, I mean I can't explain more using this graph at this point of time, but we'll have to go a little more deeper. Okay, equilibrium means the forward rate and the backward rate both are equal. That's why equilibrium. Look at this. This also is stabilized. This also stabilized with the same rate they tend to move. Okay, here you can see a massive change. it goes extremes. It has to go extremes, or else you can't form products. Okay, and the reactants will be aware of it. It's not like they're not aware. They know that the one extreme shit is going to happen, and that's all. Okay, we'll let 1 to 2 points below this, and we'll talk about the next things.
We have class tomorrow.
What's it tomorrow? We'll have class tomorrow.
Always.
I know.
Shit.
No. Apparently, phenomenon is there. So,
Saturday also?
nobody's going phenomenon. Very good. Then come. We'll have class tomorrow.
Saturday also?
Where?
No. Tomorrow?
No class on Saturday, no sir.
Don't keep on
Class
Saturday.
on Sunday, no.
No, Saturday.
Why?
We are going.
Don't go.
Tomorrow also I'm
Fuck
not
up
going.
and come equilibrium. I'm doing no. I'm telling you, 5 o'clock finish and come. From
Sir.
morning to 11.
Sad.
Yeah, no.
DJ starts at some 6.
7 o'clock.
Can you listen?
Ah, no. No, DJ. Who's saying no? Oh, wait one thing. Saturday,
Morning in class.
Oh,
no college. This Saturday?
I'm putting holiday. I have tomorrow holiday.
we have college.
College is there, bro? No. क्या चला है क्या? जरा क्या? नहीं जरा. अच्छा. मैं अपना. David, where are college के?
We have college.
You're going to play?
What time?
Regular college.
8 o'clock.
8 to 12.
12:30.
See to 4:30, okay?
Okay.
What?
Ah.
Right? 3 to 4:30. Finish off, no problem. Then you go wherever you want. What, pa?
Can't you do earlier?
He has 9th standard Spurti.
I also have 12 standard for
He has 12th
What
standard.
what time is their class?
Huh?
What time is their class?
Weren't you in 9th tuition?
Huh?
Just tell that if you know, bro. What?
Can't you do early morning, sir?
That 12:32 to no.
Can't you do earlier than that?
Earlier than that,
College we are.
college is there.
Oh,
They are in college or in school. They go to college basically.
bro. Okay, bro. Sorry. I'm sorry.
What's the?
I'm
what's
sorry
the,
for
what's
asking
the-
a question also.
Ask that auntie.
Fine, what?
Question
So
with 3
3 to
o'clock.
4:30. Huh?
Hey, what's the issue with 3 o'clock?
Simply.
What?
Simply.
Get out of here.
Huh?
Sir, ನಾಳೆ ಎಷ್ಟು ಗಂಟೆ ಸರ್ ಕ್ಲಾಸು?
Ayo.
What class?
Nale. Which time, sir?
ನಾಳೆ regular class.
Regular class on.
ಓಕೆ.
Talking about Saturday, tell him. Ask him to stop texting.
Stop texting and Saturday 3 to 4:30.
Yeah. Okay, no.
I'm fine.
ಅಲ್ಲ ಅವನ್ನ ಕೇಳೋದು ಅವ್ನು ಬಿಸಿ ಮ್ಯಾನ್ ಅದು ಹೇಳಲ್ಲ. Okay, 3 to 4:30. Okay, then Saturday we have to 3 to 4:30. Finish off. Then you go to Cameroon lady, Ramanan. What Dabakul? You are right, Ramanan?
Maybe he'll tell that you'll see him there.
Maybe he'll change. First point under the graph, right? Initially, comma, concentration of R. Listen, don't write the phrase. Wait. How do you write the shortcut?
Or
You write R within square brackets. Initially, concentration of R. Come on, this bro. I'm telling you. Is higher compared to concentration of P.
we have holiday tomorrow.
Wait, yeah, correct.
Huh?
Kannada something.
Some all government colleges.
Government college over there.
No, dude, they're coming to our college.
Wait. Therefore, rate of the forward reaction. Therefore, rate of the forward reaction is higher compared to rate of backward.
What would you done if I didn't come to that?
Nothing, bro. You are not big people, bro.
Tell you.
Get your pull from Paris for a means. Where will I go?
Sir,
Actually staying in a bar.
No.
He's scared also. Coming in Malabar. What bar?
why is your area road so shit?
You don't know how to drive it up.
See my road is like that. My road. So I'm too upset with now. Second point. As time keeps passing, put a comma. Concentration of R decreases. Use the shortcut. क्या लिखा? Oh. Sphere. What? decreases, and that of the product increases. I mean, square bracket P, and that of the product increases. Therefore, look at the progress. Rate of the backward reaction, okay, is greater than rate of the forward reaction. Just write that. It's easier.
Sir, my attendance 63%, sir.
Happy you are, just before you article, don't worry.
Speak to him. He doesn't go to college. He doesn't go to college.
So much he's kept, bro. People.
63, no, hey, 63 is good. Appreciate that.
But 60 category is done, yeah.
Like third point.
Bro, you know Hariya from my college. That guy, he's kept some 24% attendance.
Pakka next is outside.
Sir, what?
One fellow has 42% in our class.
Minimum.
Intelligence percent.
When SAS class, he doesn't come. So Hindi class, he went in silent. This guy, Hariya.
I think
He has some 8% attendance in Sanskrit.
I think it was Muhammad Muiz.
Ah.
Yeah, that guy. He has 42%.
Next point. Therefore, I mean third point.
Epic house.
After a certain time interval. Third point. After a certain time interval, RF equals RB. RF equals RB. Open brackets. Equilibrium. Open brackets. Equilibrium. That's all. Pa. Okay. Next heading. That's all I mean. That concept is done. Next heading. Law of mass action. Law of mass action. Okay. What do they mean by this? We'll have to go step by step here. Listen. 2A plus 1B is giving us product. I'm wantingly not talking about the letters involved in the product. Ignore it. Okay. Now if I ask you, write the law of mass action for the reactant side. Now obviously you can only write for the reactant side because only that is where the letters are visible here. Okay. Doesn't mean it's not here. We are not talking about it. So what I mean by this, I'm telling rate. Rate is always lowercase. Okay. Is directly proportional to the, don't write, listen. Rate is directly proportional to the concentration of the reactants. Okay. Concentration of the reactants raised to their stoichiometric coefficients. Repeat that. Concentration of the reactants raised to their what? Stoichiometric coefficients. Now let's go step by step. For this, I'll give you an easier example. I am telling I'm only using one reactant named as A, and this reactant is becoming product. Now, do I know the product to be more precise? I don't know. Ignore it. So if I ask you to write the law of mass action or the rate equation for this specific equation, you look at the reactant side first. Is there something visible here? Yeah. What is the reactant in this case? A. So you write rate is directly proportional to the, I said, concentration of the reactant. How do you write that, the short form? Agree? To be more precise, can I tell? Rate is directly proportional to the molar concentration of the reactants raised to the power of their stoichiometric coefficients. What number is there? 1. You will write this. The next step, you will be like R. I don't want the proportional symbol, so we always introduce a constant. Usually the constant will be K. You write K, concentration of A to the power 1. This is the law of mass action for this specific assumed equation. Why is there only one thing? Because how many reactants were actively being used here? One reactant. Let's talk about this. How many can you see? How many reactants can you see?
2.
2. What are they?
A and B.
Proportional to the concentration of A to the power
2.
2. Then whatever happens, don't put the extra dot and all shit like that. Nothing is required. Okay? Give some space. To the power B, power 1. We don't want this. So what do we do? R equals K, concentration of A
Square.
That's how you write the law of mass action, also called as what equation? Rate equation. You know here? No? Rate is always lowercase. Why not uppercase? Because usually we use uppercase R to write to represent what? Reactants. That's it. Okay? Avoid that. So heading law of mass action, just copy this one example.
And wait, the molar concentration is also called what mass?
Active mass. Molar mass. Active mass. Gokul, ಅಂತ ಆನ್ಸರ್
ನೀವೇ ಕೊಟ್ಟಿದ್ದೀರ
ಈಗ ನಿಮ್ಗೆ ಬಂದ ಅಂತ ಹೇಳಿ. Done? Check, I don't know. And active mass always depends on, law of mass action always depends only on your reactants. So, what law involves both the reactants and products? If your question is that, next heading. Law of chemical equilibrium. Law of chemical equilibrium. Okay, now please put a pen down. This is like the important stuff. A plus B, reversible reaction, tends to become C plus D. Agree? Now when I'm trying to use the word forward reaction, what is actively getting used up? A and B or C and D? A and B are getting used up. So in this case, forward reaction meaning A and B are active. That's what you will think. You will not tell reactant side is active. Avoid that word. Because in the backward reaction, this becomes the reactants. So it is not advisable to use the word reactants. It's advisable to use the actual letters. Okay. So since I'm talking about RF, rate of the forward reaction using the concept of law of mass action, I'll write is proportional to, in the forward reaction, what letters will get involved in this case?
A and B.
A and B. So I'll write concentration of A to the power 1. I'll ignore. Leave some space. The concentration of B. Get out here. So now I'll write RF. I don't want the proportional symbol. I'll write equals. I'll write K, but with a 1 I'll write because I know by the looks of it, this side also will go later. Agree? So I'll be getting two constants, obvious. So in order to differentiate them, I'll write K1. The other thing remains the same. Concentration of A and concentration of B. RF because rate of what reaction? Forward reaction. Next. Now we tend to reach here, but when it reaches, this also wants to contribute. How does it contribute? By going back. Going back in the sense, what reaction is called? Backward reaction. So how do you find the rate of back? Okay, when it comes to a concept called as rate of backward reaction, what is used? What letters are used? So you write proportion to what? Concentration of C to the power 1. Concentration of D to the power 1. Now RB I'll write equals
K2.
K2. A, oh my gosh. C and D. Now I'm giving you a condition. Now what does the condition mean? I am telling you, at one point of time, they will attain equilibrium. I'm telling you this. Okay. They will attain equilibrium is English. The chemistry meaning is the rate of the forward reaction equals rate of the backward reaction. Go back to the graph. Go back to the graph. Read the third point. What does it say?
After time interval.
After time interval, RF will be equal to RB, and that is called as what condition? Equilibrium. Now I am trying to tell you this. Do we know the answer for RF right now? What is it? K1 concentration of A times concentration of B equals K2 concentration of C concentration of D. Next people get confused. Guys, tell me honestly, when you are trying to add something and called as a reactants, we are expecting what? Product. So, reactants, why aren't we expecting? Because we are the ones who've invested it, we bought it. So we don't expect the same thing. We be like, I'll use A, I'll use B, hopefully I get something else. You get? So what are we curious in trying to get? Are we curious in trying to get C and D or A and B? Think from our perspective. C and D. So according to us, I want C and D to always get the most important priority. So according to us, can I tell both C and D belong to the what side? Product side or the reactant side?
Product.
So product is what is more important for us, which means importance how will we show? We will make sure that the C and D will remain in the numerator. You note there. Fine. So what happens in the next step? Concentration of C and concentration of D will remain there. What am I trying to do? I am trying to differentiate or separate all the concentrations with the constants. I am trying to bring the constants one side, variables the other side. Okay. Concentration of C, concentration of D done. Now, what other concentrations have the ability to come to the RHS? Obviously, concentration of A by concentration of B. What was already there in terms of constants?
K1.
K1 was already there by
K2.
correct? K1 by K2 is called as, can I tell? Rate constant of the forward reaction. What does K mean? Constant. We got the constant when trying to find what? Rate. Therefore, rate constant. Don't get confused. Two words are there. Rate meaning R. Rate equation meaning this. Rate constant meaning K. So repeat that. Rate equation meaning full equation. Left side, right side, everything is involved. Rate constant meaning K1 and K2. Okay. Then rate meaning R. That's the meaning. Okay. Now K1 by K2. Concentration rate constant of the forward reaction by the rate constant of the backward reaction will be called as equilibrium constant. Understood? I'll write K, but I'm going to write equilibrium because at this state it attains equilibrium. That's the meaning of it. Okay. At this point of time, don't write it. The next step will do it. But any doubt here? No? Good. So first I want you guys to copy all these things. We'll talk about the meaning of the different letters. Oh, okay. Listen up, guys. I'll write it only. What's the meaning of R only? Rate. If I write RF, it means rate of the forward reaction. RB, rate of the backward. For equilibrium, what's the condition? RF should be equal to RB. Okay. Now, what's the meaning of KF?
Constant of forward.
Of the forward reaction?
Rate constant of forward.
Rate constant. Okay.
Rate constant.
Rate constant. I told you the origin of this because it's a constant. It is appearing when I'm trying to find the word rate. That's why. Now, if I write R equals K into concentration of A into concentration of B, what is this called as?
Rate equation.
Rate equation. Given by the what law? The previous law. Law of
Mass.
active mass. Active mass. You're getting it? Or what is that?
Mass.
Mass action. Same. Okay, I'll scroll a little down. This is not important initially. Once you do everything on your right extreme, you copy these things. So start off with A and B. Try to do on your own, no, actually. Then we'll talk about the remaining things. Well, Cool. Check. Now one last step. Again, we spoke about this. We got it. Listen up. This is rate constant of the forward reaction by rate of the backward reaction happening at equilibrium. So we call that as what? K EQ. K will be called as what constant? Equilibrium constant. It will happen only at equilibrium, nowhere else. It will happen only where? At equilibrium. So add one extra step there, write K EQ. And also write that here. K subscript EQ means equilibrium constant.
Best part is they wore Korean formals for the Japanese ones.
How is Korean?
No, the dressing sense. This is Korean.
Yeah.
Yeah.
What's the difference between the regular?
You are the one who gave.
You asked it.
No, but what's the difference between the
Okay, Koreans have
Is it
more.
because that the bell bottom jeans and pants?
They're more baggy, and then the shirt, formal shirt is like Indian model.
I see a lot of Korean businessmen they make in that like this.
But how do you differentiate it? Like, I don't understand. Because when you go to the tailor, because that's the measurement distance.
Oh my god. Show sir.
Bro,
Like
which
yours?
anime character
No.
is that? Bro,
It's paid.
Yeah.
you
Nikhil, bro. He acts like that also. He acts like how he looks.
he looks even scarier than Kanchana, bro.
I'm telling you, one call you go on with him, you'll be traumatized. He'll start meowing, barking, everything he'll do.
Yeah, just do that.
Then, wow, meowing, barking all this time pass, thanking only.
Oh, yo, oh my god.
Oh, you what?
No.
It's totally the same, bro. It's amazing.
And
Yeah.
That's good. Hey,
Narayan to comment.
oh my God. He'll be like it. Next heading, right?
time up, sir.
Hey, comment right, uncle.
To answer, take class now. Please stop.
जरा माता पाए देन को नंगे टेंशन आता है बताओ. Okay, that's the equation. I just have one question. You'll find that. Directly, you'll write it. Okay. Write the equilibrium constant for this. Equilibrium constant. Directly. I don't want any direction. Directly. Why? A into he told. Guys, don't write steps. One formula, one answer I want. Last answer.
To the power x. C to the power r. Hey, yeah, no.
Sure.
Wait a
Why
minute.
he told A bar extra?
I'm writing.
Guys, equilibrium constant. Now please don't write K1, K2. Why? Is it given to us? Not given. You will again. There are few questions. They give you K1 and K2 or Kf by Kb. How do you do it directly? Listen. Again, we think always about the what first. Products or reactants. So products have to be given the priority. But what of the product? The molar concentration of the product. So you write molar concentration of C. Do we have any stoichiometric coefficients here? To the power R. No dots. Nothing. Give some space. Concentration of D to the power
Yes.
S divided by concentration of A to the power X.
Right.
But this, have I written K1 by K2? Don't try it because that's not a numerical kind of question. Okay. One more. Yeah.
You write it at this rate.
Hmm?
The compound.
Yeah.
have this in 12th too. Like,
Done. Fifth answer. Left hand side will be K. EQ. Correct. First, what's more important?
chemistry. Oh,
Sure.
yeah.
H
3.
to the power
2.
by.
And 2.
Okay, is there 2 on top or bottom?
Bottom.
Nara top ಅಲ್ಲಿ ಇದೆಯಲ್ಲ Davida. Hey, our I will go top. Power is what's the power for N2? And here.
H2 to the power 3. You don't need to show one now.
Whatever. Alright? Guys, now the same thing, whatever we represent in terms of molar concentration, no, can be represented in terms of pressure as well. How do we do? Listen, don't write. I'll write K, I'll just write P. Okay? At pressure, first important thing is you will take off the square bracket because square bracket has a special meaning, correct? So now what do? You write regular brackets. You will write P subscript. What's the component used? NH3 square. Everything is the same. What changes? The variety of the bracket changes. Along with, you will add one extra P. So it becomes pressure of N2 to the power 1. Pressure of H2 to the power 3. Need out here? So this is with respect to partial pressures. This is with respect to concentration, partial pressure.
Each bracket here is the partial pressure of that particular.
Correct. Most important thing is the bracket. You put square bracket and write P inside, doesn't make any sense.
Do we write this?
Yeah. Write KP. It has to be lowercase p, no uppercase. And for the lowercase p, subscript will be all the required components. समझ में आया क्या रे? हाँ, कल पूछूंगा. ऐसा क्या तो? Okay. The answer of अंदर का. तब अंदर का. Baca nama dia berapa? Nana. Ah?
Over no. I might say.
Okay. For one more thing, you guys said. You will write both KC. It's called as guys equilibrium constant meaning KC also. Okay. So you will write K equilibrium and you will write the partial pressure both. Start. Direct answer. Vinay, careful. Careful. Well, yeah. High order. High square. Brother, you shall look at this. What is this? What bracket is it? You shall draw. One like this is good. Look at it. Look at that.
Best way you read this CR7.
CR7 very good.
Oh, which one I wrote it?
CR7 very good.
Sir,
Okay.
linear equation.
Huh?
Linear
No,
equation.
no.
Ronaldo is the good.
Okay. Okay. One cup we have. FIFA. Not that. FIFA spelling, you know? FIFA la FIFA.
Yeah.
Nenada.
That's why I feel.
Argentina. Huh?
Very high.
ಕಪ್ಪೆ ಹೈಟ್ ಏನಲ್ಲೋ ಫುಟ್ಬಾಲ್ ಏನ್ ಐತಲ್ಲ ಆಡ್ತೀಯ ಹಾಲ್ ಅಂತ ಆಡೋದು Ball on the outside, yeah. Height is there for football, basketball.
So where's his width? You should ask.
What ra? Concentration of HI, the part.
Even you don't hide.
See what thinking? I will tell. What thinking is that? Thinking, but texting and
Whatever it is.
Ajit, you tell. What is this? Two highs. You will pay off now, don't take it. What is this? Tell ra. You get a answer with it, okay? Tell ra ba.
What are you trying to do right now?
Hey. Then guys, both of them?
Ah.
Okay.
Bye.
Bye bye.